All right, so last time we were here, we looked at using what's called the zero factor property, right? And to use the zero factor property, or the zero factor property, used to solve what kind of equations? Quadratic equations. Handwriting is really good today, isn't it? And remember that you know that something is an equation because it has a what in it? An equal symbol. Good. If it has the equal symbol, you know it's an equation. And there are certain steps common to all equations. How many? 3 steps. So don't forget that those 3 common steps have to be completed before you move on to start solving the equations. You've got to clean it up to get it ready to solve. Then after you clean it up using those 3 steps, then you know that what kind of equation it is by looking for the exponent. And if you see that the highest exponent is a 2, that's what makes it what? Quadratic. And there are lots of different methods for solving quadratics, and we're going to look at several of them. The first one we're going to look at is something called the zero factor property. The zero factor property, remember the steps for that? First step is to set it equal to what? 0. You have to have every term on one side of the equal symbol. If you don't, then it's not going to work, period. So make sure you're learning all the steps in order. Second step is to what? Factor completely. Remember, when you're factoring, that means first look for the GCF, then count the number of terms, because the number of terms is going to determine what method you use for factoring it. After you have it factored completely, then you're going to take each one of those factors and set those equal to what? 0. Now remember, please tell me that this has not been not recording this whole time. I don't think it has. Oh, I'd be so mad. All right, x minus 2. Is there a GCF for x and 2? No. How many terms is that?
2.
If there are 2 terms, then it has to be the difference of 2 squares. It is a difference, but are x or 2 squares? No. So will this thing factor?
No.
Now, even though it doesn't factor, I do want you to do something to it. I want you to put it in parentheses, because that tells you that it's one factor, x minus 2. Okay? X is a monomial. Monomials never factor. So let's go to the third one. X squared minus 2x. Is there a GCF here?
No.
Yeah, that's okay. What is it? Yeah, there's an x in both of them, isn't there? So let's divide out an x and we get x minus 2. Look inside the parentheses. It's a difference, but are they squares?
No.
Nope. So that's our factored form. Okay. Now that we have it all factored, we're going to use those factors to build our LCD, starting with looking to see if we have any factors that are monomials. Do we have any monomials? Yeah, x and x, right? Does x divide evenly into x? So what do I need? X. Not x squared. If x divides into x, then I just need x, right? Okay. Then I'm going to start bringing in the parentheses, starting where? With the first one. What is the only parentheses in the first one? So I need to put an x minus 2 in my LCD. Go over here, then no parentheses there. Here's a parentheses, but what is it? It's x minus 2. What do you notice, though? We already have an x minus 2, so do I need another one?
No.
Nope. So this thing is my LCD. Okay. So if you know the process is dead easy. But if you don't learn those steps, you'll never make it work. Okay? So you've got to understand the steps. Yes, ma'am.
Okay, so when you got the x on the LCD, because on the third one, the x,
X here and X there.
so that
And-
x on the outside, meaning it became a monomial.
Right, it's a monomial factor because it's only one term.
Not divided
Right. It's only one term. So x divides evenly into x, so that's why we needed an x. Okay? And if you look at this actually follows that other rule that we had about the smaller one dividing into the larger one. Which one of these is the largest denominator? That one. Does x divide into it? Yeah. Is there an x minus 2 in it? Do you notice that the LCD is actually the same as the biggest one? Okay? So it follows that other rule too. Now that's not always the case. They won't always factor to be that way, but many times that's the case. All right. Now, before we move on and look at another LCD, I have another note to make for you. If your LCD has a variable in it, what's a variable? A letter. So any LCD that has a letter in it, no matter what letter it is, okay, set it equal to 0 to find out what X can't be. Now, somewhere in your long distant past of working with fractions, which is everybody's favorite topic, you learned that there is one number you can never accept in the denominator of a fraction. Do you remember what it is? 0, right? Because if you have a 0 in the bottom, you can't divide by a 0. So that makes the whole thing undefined. So you can't do it. So we can't accept any number that makes the denominator equal to 0. So any value for x that turns our denominator into a 0 is forbidden. It's off limits. Okay? So what we're going to do is, and we know that that's going to happen anytime that there's a variable in your LCD. So what we have to do is take each one of those pieces of the LCD that has a variable in it, set it equal to 0, and solve, not to find out what x can be, but what? What it can't be. So let's look at this one we're working with here. We already have our LCD. It was x times x minus 2, right? Does that have a variable in it? Yeah, both factors have a variable in it. The monomial is a variable and the parentheses has a variable. So what I have to do is set each one of those equal to what?
0.
Sounds familiar, doesn't it? That's what we did when we solved a quadratic, wasn't it? But this time I'm not looking to find out what x can be, but what it can't be. So instead of the equal symbol, I like to use this little slash across it, which is not or cannot equal 0. Because I'm not looking to find out what x can be, but what it can't be. Right? And you just solve by doing the opposite. Well, this one's already done. X can't be what number? 0, comma. This one, add 2, and x can't be what?
2.
Positive 2. Now again, these are not the solutions. These are the things that can't be solutions. And how do I know that I had to do this? I just wrote it. Look up at the last line I wrote. The LCD had a what? A variable in it, right. Remember, if your LCD has a variable in it, you have to set it equal to 0 to find out what your x can't be. So that's why I did that. So x can't be 0 or 2. Remember last time we were here and I said all quadratics have 2 possible solutions? Well, this is how you end up with the ones that it can't be. So what if I got 0 as a solution? Could I keep it?
No.
I'd have to throw it out. Okay? What if my 2 solutions were 0 and 2? Did I get to keep either one of them? No, yeah. And if I throw out the only solutions I have, then there is no solution to the problem. Okay? All right. So but you only have to do this when you have a what in your LCD? Which is almost every time. So you might as well just get used to it. What I do is, because I always forget it, is I go ahead and set them equal to 0 no matter what. Now, notice I showed the setting equal to 0 here and here. You don't even have to do that because you remember that it's always going to be when you have these and you set them equal to 0, basically any monomial, and that's a monomial, is always going to give you a 0 no matter what it is. If it's 4x, that's a monomial, so what is x going to be? 0. If it's x squared, that's a monomial, so it's going to be 0. Any monomial always leads to 0. And for x minus 2, all it's going to do is change the sign. So you don't have to show any work here if you don't want to. You can just give me a list. I don't have to see the work, but I do have to see the list. And if you don't show me this list on a test, that's minus 4 points. Stupid thing. Please tell me this thing didn't just go dead. That's all the battery I get? Okay. Okay. My life is not
So we don't
going well
have to
today.
do the x not equal to 2 because we already have the x not equal to 0.
No, you have to do both of them. I need to see both of them.
So those
0 and 2.
I mean, you don't have to do the X.
But you don't have to show me adding 2 and all that crap, all that stuff. Okay? All right. Now, so we've talked about the two cases for finding the LCD. Now your factoring can change, right? But you're still just going to bring in those parentheses. So you'll see examples of all of these. Now, but that's only the first step, is to find the LCD. There's a lot of stuff in there. After you find the LCD, because remember, we're talking about clearing fractions here, and it says to clear the fractions from an equation, the first thing you have to do is find the LCD, right? Okay. Now we need to know what to do with that LCD. So step 2. What you're going to do is you're going to multiply that LCD times every term. Now, did I just say just multiply it times the terms that have fractions in them? Nope. I said you have to multiply it times what? Every term. Because remember, you can do anything you want to an equation as long as you do it equally. Which means I can multiply by anything I want to as long as I multiply it equally times every term. Now, when you're doing this, there's a pattern that you can use, and that'll make your life a lot easier. And I want you to learn this pattern because we're going to use it a lot in this course to do a lot of different things. Here's the pattern. Now, this is the pattern for working when you take an LCD times a fraction. You don't need the pattern if you're taking an LCD times 7. Okay? You multiply by 7 like you always did. But if it's a fraction, you need the pattern. Okay? The pattern is called divide, then multiply. So I've got two different operations going on. I've got division and then what? Multiplication. And you have to do them in order or it won't work. Which one comes first? Divide. And then what do you do after that? Multiply. Now what happens when you divide stuff? 8 divided by 4, you get what? So in other words, a lot of the number disappeared, didn't it? Division takes stuff out, doesn't it? And that's what's going to happen here. When you divide these, some of the factors disappear. And so you're going to be multiplying with a lot less stuff than you started with. Okay? As a matter of fact, anytime you divide something by itself, what does it turn into? And would you multiply by 1? No, because 1 times anything is the same thing you started with. So in other words, they just divide away. So you don't care about them anymore. So anything that's the same will simply divide away. And what you're going to do is multiply what's left times the numerator. So here's what it looks like. You take your LCD and you divide it by your original denominator. Now I put that in parentheses because that tells you that what does parentheses always mean in mathematics? Do that when? First, you bet. You do the division first. Once you do the division, then what you're going to do is you're going to take what's left and multiply it times your numerator. If indeed there's anything left. A lot of times everything divides away. And if there's nothing to multiply with, then you don't multiply. You just keep the numerator the way it is. But most of the time there's something to multiply by. So it's LCD divided by the what? And what's left times the numerator. Okay? And once you do that, the fractions will be gone. Because anything divided by itself will go away. And we know it's going to divide evenly because that's the definition of LCD. It's something that the denominators divide evenly into. So the denominators will divide away. And if you don't have a denominator, you don't have a fraction. Good. Okay. So let's look at an equation. 2x plus 1 over x minus 2 plus 4 over x equals negative 8 over x squared minus 2x. Now the denominators here should look very familiar. This is the one I just did. First and most important thing you can ever do is identify what kind of problem you're dealing with. And this thing is an... You can't go that far yet. One symbol tells you what this is. The equal symbol tells you it's an equation, right? Remember, you can't really tell what kind it is until after we go through those 3 steps of cleaning it up. So, we know it's an equation because of the Equal symbol. Good. There are certain steps common to all equations. How many? 3. The first thing I need to, so I know it's an equation. First thing I need to look for are what? Parentheses. But do you have any? Nope. What do you look for next? Fractions. Do you have any? Yep. In order to clear the fractions, I have to first find the what? LCD. Are these monomials? One is, but what? Not all of them. So they're not monomials. So that tells me I have to do what to them? Factor them. X minus 2 will not factor. There's nothing common. It's not difference of two squares. But I do want to do something. What? Put it into parentheses. Trust me, your life will be much easier if you do that. Then, x is a monomial. They never factor. X squared minus 2x. You can take out a common factor of x, which gives you x minus 2. And it won't factor anymore. Notice that I marked off the thing that I factored. Because you don't want to get mixed up and think you need to use that anymore, right? It's gone. You factored it. Now that I have all the factors, I'm going to build my LCD using those factors. Are there any monomial factors here? Yes. Yeah, x divides into x, so I need an x. What's the only parentheses from the first one? And the only other parentheses is this x minus 2, but it's already in my LCD, so I need another one? No. But what do I have in my LCD that I'm concerned with? X's, right? There are variables in there. That tells me that there are going to be some numbers that x can't be. What are they? Monomials always give you 0. X minus 2 is going to give you a positive 2. Okay? Got to do that. So, after you factor it, then you build the LCD, and then remember what x can't be. Right? So there's a lot of stuff going on over here on this side, yeah? So this is where that method really comes in handy. This is kind of like a flow chart if you've ever done computer science or anything. So this really comes in handy so that you don't forget what it is you're supposed to be doing and when you really should practice. I'm going to tell you right now, these are the most complicated problems you're going to work in college algebra. That doesn't mean they're the most difficult. They have more steps than any other problem we're going to do in college algebra. Okay? Welcome to the third day. How fun. But after this, it's all downhill. Trust me. Okay. So, we know what our LCD is. We know what x can't be. Now the next step says I need to go back and multiply that. Multiply. That's supposed to be an L, isn't it? Multiply that LCD times what? Every term. Okay? Using the pattern. What's the pattern called? Okay, good. So here we go. If you're going to multiply everything by something, that means put it in a gigantic parentheses, right? And I have my LCD written here, and my page is small, so I'm going to go ahead and use it from there. But to have this big parentheses next to my LCD means multiply it times how many of the terms?
All of it.
All of them. Using that pattern, which is what? Divide, then multiply. So we take our LCD, which is this thing, divided by my first denominator, which is x minus 2. Remember that when you're dividing, anything that's the same will simply divide away. Yep. And you multiply by what's left. So what's the same in this denominator and in my LCD? So the x minus 2's will divide away. What does that leave me with in my LCD? Just plain old x. And then I'm going to take that x and multiply it times my what? Numerator. And what is the numerator here? 2x plus 1. Now, I like to write it down as multiplication and then do the multiplication. You don't have to, but it really shows you what's going on so you can be more careful about what's going on. And I'm going to go ahead and do the multiplication as I go. So x times 2x is 2x what? Squared. X times positive 1 is positive 1x. Now, do you need the 1? No, but I usually write them right now because I don't want to get lost. This is a big complicated process, right? Okay, so we're doing the divide, then multiply, right? Is what we're working on right now. I don't know why I can't write that. I'm going to keep writing as mutt. All right. Now, I didn't need the 1, but do I need the plus? Yes. Absolutely. Got to have it. Now, let's move to the next term. Anytime you're working with fractions, if you see a sign in front of a fraction, that sign always goes with the numerator. And it doesn't look that important with the plus, but trust me, with a minus, it makes a huge difference. So anytime you see that you have fractions in an equation, you might want to, before you even start, put all those signs with the which part? the numerator. You don't have to, but anything that can make your life easier, you should probably do. Here's my LCD, right? I'm going to multiply it times this using that pattern, which is divide, then multiply. So what's the same in my LCD and this denominator down here? The x. So the x's divide away. What does that leave me with up here in my LCD? X minus 2. And I'm going to multiply that times what? Positive 4. Got to have a sign now because we're not talking about the first term, so it's positive 4. So positive 4 times x is positive 4x. Positive 4 times negative 2 is negative 8. Okay? So do you see what's happening? Anything that's the same here and here will divide away, and you multiply what's left times the numerator. So now let's do the last one. What's the same in this denominator and in this LCD? So it's all going to divide away. Well, if everything divides away, is there anything to multiply the 8 by? Nope. So just bring it down. It was a negative 8, by the way. I said 8, but it's really a negative 8. So if every bit of it divides away, then there's nothing to multiply with. So your number doesn't change. What do you notice about this new equation that I have down here? What's missing? There aren't any what in it? Fractions. We've eliminated the fractions by eliminating the denominators. So the next step is simply to what? Combine like terms that are on the same side. Do you see any like terms on this side here? Yeah, those two x terms. So we get 2x squared. 1x plus 4x makes positive 5x's. Minus 8 equals what? Equals negative 8. Good. So I've cleaned it up. No parentheses. I eliminated the fractions and I combined the like terms on each side. That's all three steps that are common to all equations. Well, if that's the case, then what's next? Yeah, well, tell me what kind of equation it is first, right? What kind is it? Quadratic. And for quadratic equations, what method are we going to use? Zero factor property. The first step is to set it equal to what? Does it equal 0 now? No, so we'll add 8 to both sides, which gives us 2x squared plus 5x. What happens to the 8's here? Subtract away there, and 8 minus 8 over here makes a 0. Okay? So our equation is 2x squared plus 5x equals 0. After you have it set equal to 0, what's the next step? Factor completely. What do you look for when you're factoring anything? Is there one? 2 and 5 don't, but what else? What will divide into both of them? An x, yeah. Be careful, because sometimes it's not a letter. Sometimes it's not a number, but it'll be a letter. Divide an x out, you get 2x plus what? 2x plus 5 is 2 terms. Is that the difference of 2 squares? So is it going to factor any more? No. Now that I have it factored, I just set each one of those factors equal to what? Which means I no longer have one quadratic, but 2 linears. Okay, so I just solve them by doing the opposite. Well, I don't have to solve that one. It's already done. So x equals 0. Here, subtract the 5 and then divide it by what? Gives me negative 5 over 2. And I'm done, right? Check it against what? What it can't be. Remember, way back here when we found out our LCD, we said that this thing can't be what? 0 or what? And what did we get for our answers? So I have to reject the 0. Now, do I have to reject the negative 5 over 2? Nope. So the only solution that I have that works is the negative 5 over 2. Throw out the 0 because our denominator told us that x can't be 0. It's a lot of steps, huh? And y'all don't even like to do 2 steps, much less 10 or 12. Tough. Okay? I guarantee that you cannot make even a B. Well, you might, I doubt you can even make a B if you just skip these. No, there's no way. Can't even make a B because they're going to be worth 10 points apiece on the test. So you better make sure you know how to work them. The math behind it is not difficult. What's difficult about it? Knowing when to do what. Yeah. Okay? So what am I going to study? The numbers? The notes. Learn the process. Here's the deal. A lot of teachers have a problem with me teaching the process. But if you know the process, then you can apply it. Once you can apply things, then you can start seeing patterns and you can get better at it. If you can't do a problem in the first place ever, you haven't learned anything, right? So learn the process so that you can do it, and then you'll start seeing the patterns and how these things work together. Let's look at another. Say we have 5y over y minus 7 minus 35 over y plus 7 equals 490, and I know y'all hate that number, but tough, over y squared minus 49. We know that this thing is an equation. How? Equal symbol, right? So it's an equation. We know that there are 3 steps common to all equations. What do I look for first? Parentheses. Do you have any? Nope. What do you look for next? Do you have any? And since I do have fractions, what I'm going to do is I'm going to go through here and move all of the signs in front of a fraction where? So this minus is going to go up here with the 35, making it a negative 35. Okay? Just trust me, it will make your life so much easier if you go through and do that anytime you see fractions in an equation. Okay? Because when you're working with fractions, the signs should always be in the numerator. Okay? You never want to make the denominator negative, but you put the sign in the numerator. So anytime you're working with fractions. Now in the end, would I want the negative to be in the denominator? No, I put it where? Back out front. But when you're working with it, you really want it to be in the numerator to make your life easier. Okay, in order to clear the fractions from this equation, I first have to find the what? LCD. Are these all monomials? No. Nope. So what do I have to do to find the LCD first? Factor completely. Go to the first one. Y minus 7. Is there a GCF? How many terms? Is it a difference? But are they squares? No. So it won't factor, so what do I want to do to it? Good. Y plus 7. GCF? Difference of 2 squares? So what do I do? Good. Over here. Y squared minus 49. GCF? Nope. Difference of 2 squares? Yes. So it's going to be y plus 7 times what? Yeah, because y squared is y and y. 49 is 7 and 7. The first one gets a plus, the second one gets a minus. That's the pattern for the difference of 2 squares. Okay? Now that I have it all factored, I need to build my LCD using those factors. Okay? And I'm going to put it up here because I want to be able to multiply with it in a minute. Are there any monomial factors in my denominators? No? So I need to start bringing in parentheses. How many parentheses do I need from the first one? 1. It only has 1 in it, right? The y minus 7. From here, so that's that one. Go to the second one. I got a y plus 7. Do I already have a y plus 7 in my LCD? Nope. So I need a y plus 7. Now I've stacked them because I simply don't have a room to write them side by side. But really they should be written side by side because they're multiplied together. But are you okay with that? Can you deal with it from here? I know it's new, so I don't want to mess with you. So they're stacked because I'm out of room. Okay. Now, and go over here. Here's a y plus 7, but what do you notice? I already have it. Here's a y minus 7, but what do you notice? I already have it, so I don't need any more. So that's my LCD. But before I use the LCD to find out what y can be, I need to first find out what y can't be by setting each one of those equal to. But when I set them equal to 0 and solve, all it's going to do is give me the opposites. So what is it y can't be in this case? 7 or negative 7. So there's what y can't be. Now that's not what y can be, it's what it can't be. But I need to see that list. If I don't, it's minus 4 points automatically. Every question on the test is worth 10. So that can add up fast, right? I've got to see that list. Then, now I'm going to use that divide, then multiply pattern to clear the fractions. This first one's a fraction, so what's the same in your LCD and your denominator? So the y minus 7 divides away. What does that leave me with in the LCD? Well, y plus 7, right, which I take times the numerator, which is the 5y. So it's 5y times y plus 7, right? Because the y minus 7 is divided away. Let's go ahead and do that multiplication. 5y times y is 5y squared. 5y times positive 7 is what? Positive 35y. I've got to have that plus, right? So you all have to tell me the plus. Okay? Can't forget them. They're signs. Go to the second fraction. What's the same here and here? The y plus 7, so they divide away. So that leaves me negative 35 times what's left in my LCD? Y minus 7. Multiplying that out, negative 35 times y is negative 35y. Negative 35 times negative 7 is positive something. It's up to y'all. Come on, give me a number. Anybody? 245? Thank you. Remember, y'all have the calculators. Equals. Now, what's the same in this denominator and my LCD? All of it. So I just bring down the 490. If everything divides away, then there's nothing left to multiply with, is there? So the 490 just comes down. It's good? Fractions are gone. What's next? And here I have positive 35 and negative 35y. What happens there? They're opposite, so they're going to subtract away. So I get 5y squared plus 245 equals 490. Be really careful about this. If the signs are different and you have the same term, they're going to subtract away completely. Now remember, 35y's minus 35y's makes what? 0. Not 0y, not 1y, but what? 0. In other words, nothing. Okay? So, let's move to the next page. It's 5y squared, what was it, plus 245 equals 490? Thank you. Okay. What kind of equation is that? Quadratic. And we're told to solve these quadratic using the what property? Zero factor. Okay, so it's quadratic. So we're going to use the zero factor property. So what do I need to do first? Does it equal 0 now? Nope. I need to subtract the 490 from both sides, which gives me 5y squared minus what? 245 equals 0. Then, after I set it equal to 0, I need to what? Factor completely. What do you look for first when you're factoring anything? GCF. Is there one? What? Yeah, they'll both divide by 5. Remember, GCF can be just a plain old number, which gives you y squared minus what? 49? Still equals 0? Looking inside the parentheses, will that factor some more? Yeah. Sure. It's the difference of two squares again. It's exactly the same way as what we had a while ago. So y minus 7, y plus 7 equals 0. Now that I have it factored completely, I set each one of those factors equal to what? But what is the first factor? 5. So 5 equals 0, y plus 7 equals 0, and y minus 7 equals 0. Which is 3 little equations, isn't it? But one of those doesn't make any sense. Which one? This one. 5 can't equal 0, can it? So this is garbage. Just reject it. Okay? Now, don't think that that's weird. Has anybody in your life ever told you a lie? Something that wasn't true, right? Did you have to then make sure that you accepted that anyway? No, you just went, that's not true, and threw it out, right? Then that's what's happening here. If you get a statement that's not true in mathematics, it's just like a statement that's not true anywhere else. You just reject it and move on, right? Now the other ones, though, if you solve the first one, you're going to get y equals what? Negative 7. If you solve this one, what are you going to get? Now I'm done, right?
No, check it.
Against what?
What it cannot be.
And what does it say y can't be? And what did I get? So I'm going to have to reject them both. If I reject both answers, what do I end up with? No solution. And since this book uses uses set notation for your answers in Course Compass, this is also known as your answer was known as the empty set. In other words, it doesn't have anything in it. And another symbol for the empty set is that 0 with a line through it, a slash through it. That means the empty set or no solution as well. I'm fine, when you're doing it on paper, I'm fine with any one of those. the null set, empty set, or no solution. I don't care which one you use on paper, but on Course Compass, be aware that they use all three of them. So make sure you know that they mean the same thing. Okay? All right. Now I want to look at another one. And the reason I want to show you this one is because it's my favorite. How sad is it that I even have a favorite? Welcome to my life. But the reason it's my favorite is because if you know what you're doing, it's so easy that it's just stupid easy. But if you don't know what you're doing, if you're making this up as you go along, which, some of you might actually try to do, then you're going to make a mess that you can't get out of. So, now, if a math teacher happens to say that a problem that they're working in class is their favorite, what does that mean to you? Yeah, it's going to be on the test. Yeah. Do not forget that sometimes I'm going to give you hints about what are going to be on the test. So if this is my favorite, it's going to be on the test. So let's look at it. We have 6 over x squared minus 40 over x equals 14. Now, in order to make this one work, you have to really know what it is you're doing. You can't just jump in and start trying to do stuff, okay? But if you know what you're doing, then it's easy. And that's why I like it. First of all, what kind of problem is it? An equation. You know that because it has an equals symbol. So it's an equation. Well, all kinds of equations out there, and all of them have the same first 3 steps. What do I look for first? Parentheses. Do you have any? No. What do you look for next? Fractions. Do you have any? Yes. In order to clear the fractions, you first have to find the, what is it called? LCD. And there are 2 cases. The first case is when every denominator is a monomial. Are these both monomials? Yes. Well, and remember, when that's the case, you look to see if the smaller one will divide evenly into the, what is the larger one here?
X squared.
Will x divide into x squared? Yeah. So what's the LCD? If I could spell LCD. Huh. So the LCD is x squared. But notice it has a variable in it? Yeah? So I have to find out what x can't be. And remember, even if it is a square, it doesn't matter. If it's a monomial, what is it x can't be? 0. It doesn't matter. If it was 4x squared, if it was 5x to the 5th, who cares? Every monomial gives you x can't be what? 0. Good. Now that I know what the LCD is and what x can't be, I'm going to go over here and multiply by the LCD to find out what x can be. But before I start working with it, remember when you have a sign with a fraction, you need to put that sign where? In the numerator, yeah, in the top, because when we're working with them, we want them in the numerator. Otherwise, what's going to happen is we're going to lose them, we're going to miss them. Okay? Now, when we're clearing the fractions by multiplying by the LCD, we're going to use that pattern. What's the pattern called? Divide, then multiply. We'll take the LCD divided by the denominator and multiply what's left times the numerator. Well, what's the same here and here in the first one? So it just divides away completely, so what's that going to leave me with? My 6. There was nothing to multiply with, so I didn't multiply it. Now go to this next one. We take x squared divided by what? What does x squared divided by x make? Times, what's my numerator? And which makes negative 40x. Okay? Now let's do the last one. Is there a denominator?
No.
So is there anything to divide by? So what do? I just multiply it like you always did, right? If you don't need a pattern for multiplying x squared times 40, right? You need the pattern when you're multiplying with fractions. So x squared times 14, is 14 x squareds. Okay. So be careful. If there's no denominator, then there's no division, just multiplication, just like always. Okay, clear the fractions. Are there any like terms?
No.
Nope. What kind of equation is it? Equation?
Quadratic.
Quadratic. How do I know it's quadratic? Highest exponent's a 2. What's the process called for solving a quadratic?
Zero factor.
So what do we do first with the zero factor property? Does it equal 0 now? No. I could move this 14x squared over there, but if I do that, I'm going to do it by subtracting, which is going to make it negative. Or I could move the 6 and the negative 40x. Which one do you want to move? I would, because it keeps the x squared positive. You're going to have to rewrite it anyway, so who cares? It's not that much to rewrite. When you do that, I get my 0 over here, because those subtract away. 14x squared plus 40x. Why not put that one next? Descending order, because the next step after you have it set equal to 0 is to factor completely, right? So, does it matter that my 0 is on the wrong side? No, don't worry about where it is either. Okay? So again, my equation was 0 equals 14x squared plus 40 minus 6? 40x, thank you. All right. My memory is not what it used to be. Then, what's the next step? Factor completely. Is there a GCF here? Yes, there is. What? 2. Divide them all by 2, you get 7x squared plus 20x minus 3. And dividing by 2 didn't seem to have much effect with it, but it did make your numbers smaller. And what do y'all like? Smaller numbers, yeah. Okay? Now, it still equals 0. Now look at that. I flipped the 0 on the other side. Does it matter? No, because if 0 equals something, that thing equals 0. It doesn't matter where you have it. I usually like to stick the 0 at the end when I'm working on it to get it out of the way. How many terms inside? So I'm going to take 7 times negative 3, which is negative 21. Looking for the two factors of negative 21 that combine to make 20. Well, duh. What are they? 1 and 21. Only if you subtract them, which tells me the signs are the same or different? Different. And I need to get a positive, so which one needs to be positive? 21, right? It all had an x up there, so they need an x down here. 7x squared and negative 3 just come down, which means I have 4 terms, so break it in half and factor by grouping. What will divide evenly into the first two? X, right? Which gives me 7x minus 1. What do I do with that plus? Bring it down. What will divide into 21x and 3? Ooh, be careful. 3, and you're going to get a 7, right? Okay, which gives me 7x minus 1. So that makes 7x minus 1 times what? X plus 3. But remember we had a GCF up there? So don't lose it. Still part of our factoring, right? Not part of our... Then we take each one of those and set it equal to what?
0.
Well, 2 equals 0. It's garbage. I'm going to throw it out. Why? 2 doesn't equal 0, and it never will. 7x minus 1 equals 0, and x plus 3 equals 0. Solve these two linear equations by doing the opposite. So here I need to add the 1 and then divide it by what? If you add a 1 and divide it by 7, you get 1 over 7. Here I just need to subtract the 3. Subtract the 3, which gives me negative 3. And are those my answers? I don't know yet. I've got to check it against what I can't be. What was it that x couldn't be?
0.
But is 0 one of the numbers I had? No. So what does that tell me? They both work. I get to keep them both. So, okay. All right. I want to show you one more thing. What if I had this? Don't worry about the denominator. I'm just talking about there's a negative in front of this fraction. Where does that negative need to go? But when I move it up to the numerator, how many terms are there up there?
2.
So it's going to make my x negative, but what? Right. When you move it up in the numerator, if there's more than one term, it has to be distributed to both of them. So what if it was a minus and it was x plus 2? When you moved it up there to the top, it'll become what? Negative x minus 2. Remember, if you have more than one term in the numerator and you put the minus up there, it's got to be distributed to all of them. Okay? All right. Now, the only thing that can change on you is your factoring. Also, remember that if you had that, that's divide then multiply. But would this one be divide then multiply? Why not? Because there's no denominator to divide with, right? It's just multiply. Can't use divide then multiply if it's not a fraction. Okay? All right. So you have your assignment. Practice clearing the fractions and working with these. So you've got your assignment, you're ready to go. The next time we come here, we're going to look at some other methods for solving quadratic equations, because remember there are several methods for solving quadratic equations. And so the next thing I want you to take a look at, if you want to review, is the radicals, which you often learn them as roots. Okay? And if I get really ambitious, I'm going to go to my office today and make you a lesson, a video lesson on working with radicals, because I can't take the time in class to do the background. This is one of those background things that you're supposed to bring with you. Remember, the roots, radicals simply mean taking the square root of a number. So square root of 9, 3. But the square root of 12, there's no number that makes 12, so you have to be able to take the square root of it, though. Remember that, taking the roots of numbers that aren't perfect squares. So what I'm going to do is I'll go to the office today and I'll make you a video lesson. Now, this is all you. That means you have to spend your time looking at this, because this is background information. I'll put it out there for you, but I'm not going to teach it in class. We'll use it in class, but I'm not going to teach it in class. But I will give you a lesson so that you can see, because as you've seen, I kind of use different methods than the books used and stuff like that. So you might want to check it. All right. See you later. Thanks.
So is that video going to be like the same way?